Gracias. Lo siento, pero hablamos inglés solamente. So in English, the title of our talk is 6 Degrees of Domain Admin. This is a play on this phrase that we have in the United States and I think worldwide of 6 degrees of Kevin Bacon, where if you have the actor Kevin Bacon, you can make a connection to almost any other actor or director or anybody involved in film and TV by going a maximum of 6 steps away. So Kevin was in this movie with this guy, he directed this gal, you know, you have that connection that way. So that's a play on the 6 degrees of Kevin Bacon game. Thank you for the introduction. I'll go through this really quickly. My name is Andy Robbins. I'm the Offensive Network Services Team Lead at ATD at Veris Group. ATD is the Adaptive Threat Division. I have spoken at B-Sides Las Vegas, DEF CON 24. We presented at Black Hat Arsenal this year in Las Vegas as well. I do red team training for Black Hat, including Black Hat in Las Vegas and also Black Hat Europe next week. And then we just had word that we were accepted for Black Hat Asia and Singapore as well in March. A few people that I've met here work in banking here in Argentina and South America, the greater South America. Banking is kind of where I cut my teeth, so if you want to talk about ACH or SWIFT or other payment methodologies, I'd like to talk to you offline about that, have some interesting conversations. You can find me on Twitter @_Waldo, that's Waldo with a 0.
Hi, I'm Rohan Vazarkar. I'm actually, Andy's my boss, but I'm actually one of the pen testers at ATD. I've been in InfoSec for about 3 years. I've worked on a bunch of open source projects. Oh, this is definitely the coolest one. I presented at B-Sides DC, Las Vegas, Black Hat Arsenal with Andy with DEF CON, and I'm also one of the trainers at Black Hat. So you can find me at Captain Jesus on Twitter.
And then finally, a third presenter who couldn't be with us, he's with us in spirit, is Will Schroeder. He's on Twitter @harmjoy, that's harmjoy with a 0. Will's most well-known work includes PowerShell PowerView, PowerShell Empire. He worked with Lee Christensen on a very interesting project called Key Thief that's used to extract key material out of memory when unlocked KeyPass database is running. Very, very interesting work. Will is also a PowerShell MVP. He was honored by Microsoft with that designation earlier this year. We have this set up for Will because Will's contribution to this project was as critical or even more critical than either mine or Rohan's. Okay, so I can barely see you guys out there, but by a show of hands, how many here work with Active Directory, like attacking or defending, doing pen tests or blue team? Okay, quite a few of you. So Active Directory is kind of our bread and butter. Our team does internal network penetration testing and red teaming as well. And in our experience, the most effective and reliable way to escalate rights in any corporation in the world is by focusing on Active Directory, having access to the Active Directory enterprise admins, domain admins, whatever, when those users typically have access to everything. And if they don't have access to what you want to get access to, they have access to the user's workstation who does. So I want to talk a little bit about the current state of Active Directory domain privilege escalation, and start off with this quote from John Lambert, who's the general manager at the Microsoft Threat Intelligence Center. John said, "Defenders think in lists, attackers think in graphs. As long as this is true, attackers will win." In our experience, this is extremely true, and I would just keep this quote in mind as we're going through our talk. So Active Directory, of course, is ubiquitous. Sean Metcalf gave a talk at Black Hat this year where he said that 90 to 95% of the global 500 organizations in the world use Active Directory as their directory service. it might be inappropriate to use the word monopoly when you're talking about Microsoft right now, but so what does that ubiquity mean? Ubiquity with Active Directory means that there's a lot of attention that goes to Active Directory. There's a lot of research time, dollars, sweat, blood, tears, where people are trying to figure out what are the most effective ways to attack and defend Active Directory. And so for us and for teams like us, we benefit from that research time and money in the form of like easy buttons that we get every so often. One example would be like MS 1468, where any domain user can automatically become a domain admin. Another example is, of course, MS 08067. Another example, which is actually still extremely common to see, is using Responder by Laurent Gaffey, formerly from Spider Labs, where if a network doesn't enforce SMB signing on Windows systems, you can capture an NTLM authentication request, forward that to some other system, and gain the privilege of whatever user it is whose credentials you're forwarding to that other system. So the bad thing about these easy buttons is that they are ephemeral, meaning that they have a tendency to disappear or go away. So with MS 1468 as an example, when that patch came out and the associated exploitation of that patch was available to everybody, we as pen testers, we had a great like 2 or 3 months where we could go into almost any network and have domain user access and turn that into domain admin without having to do anything else. We don't have to do any kind of like port scanning or really gain any other kind of situational awareness about the environment. We could just hit a button and become domain admin, and it was awesome. The thing is, that lasted for like 3 months, and so while that was great and while all these other exploits are awesome, they have a tendency to go away because as organizations mature, their vulnerability management practices, their patch management practices get better, and that window of opportunity that you have to exploit a publicly known bug goes away. So, put into like a visual way, I'll talk about like what a typical pen test that we go through at like a first-year client or an organization that has immature security practices looks like. So as an example, we have these 16 computers here, and the kind of dotted lines mean that we know that those computers are there, but we don't have any access to them at the time. This red computer that is going to light up red, there it is going to mean our initial access, our initial foothold in the environment. So maybe we sent a fish, or maybe we had access to the network and we used Responder to get a shell, what have you. Bottom line is we have access to this one system and we're able to escalate locally and get local admin on that system. Now, next, Will Schroeder, he put a lot of effort, a lot of time into developing this tool called PowerView. PowerView has been and remains the best tool available for Active Directory recon, in our opinion. One of the things that you can do with PowerView is you can figure out where other users in the environment are logged on. And for this, you don't need admin rights. So with this specifically, I'll talk a little bit more in detail on a next slide. But we can figure out where the domain admins are logged on. So as an example, we're a local admin on this red box. We know where the DA is logged on. As a local admin, we're able to extract the contents and decrypt the contents of the SAM, including the local admin, the RID 500 NTLM hash. Now, maybe they deployed KB 287.1997, maybe not. It doesn't matter if you're passing the hash for the RID 500 account. What that means is that if we're able to escalate locally on one system, we effectively have access to the entire environment because the local admin password is the same. So we know where the DA is logged on. We use our favorite pivoting method to establish a session, interpreter, beacon, what have you, on that system the DA is logged onto. We use Memcached to extract that user's password and clear text out of memory, and we're done. And we're awesome, and we're elite hackers, and we write the report, and the client loves us. And so that's what it typically looks like for like a first-year organization or an organization with immature security practices. So let's look at a different example where things are a little more sophisticated and a little more challenging. So again, we have these 16 computers in this example network. We have our initial access on this red system that's lit up. And in this environment, they don't have any low-hanging fruit. They don't have MS-1468. They don't have JBoss servers that are configured incorrectly or Tomcat servers with default credentials for the admin interface. However, eventually we are able to escalate our rights locally. Recently, this has been, for our team, achieved most commonly through two different methods. One is by spin scanning and Kerber roasting, which if you haven't looked into that yet, I highly recommend you do. And the second one is thanks to work from a gentleman named Scott Sutherland and Eric Gruber at NetSpy, another InfoSec consultancy in the States, called Power Up SQL. Check out those projects for details on how you can elevate rights using those different techniques. So, we elevate our rights locally on this one system, and unfortunately for us, the organization doesn't use the same local admin password for every system. They use LAPS or some other similar product to have a unique password on each system that changes or cycles on a certain interval. However, we are still able to determine where people are logged on. You can do that just with domain user level access. So we see that that's the computer where the DA is logged on. And what we want to do now is we want to figure out how do we get to that system? How do we get to the DA? So with this user who we're impersonating, we find out where do I have local admin rights? What are the other systems that I have an opportunity to pivot to? And who are the users that are logged on to those systems? So we see that there are 3 different systems that we have local admin rights on, and we have 3 different users who we could choose to go to and compromise and get their password. However, none of them are a domain admin, and none of them have local admin rights on the system where the domain admin is logged on. So we have to make a choice. We have to make an educated guess on what account we think would be profitable for us to go to. So let's say, for example, we go to this guy in the top left. We pivot to that machine, run mimikatz, get that password in clear text out of memory, and then find out where does this new user have local admin. We find out that our scope of administrator access is starting to slowly grow, and we see these new systems that light up that we now have admin rights on, and we see who those users are who are logged on. None of them are domain admins. None of them have local admin rights on the system the DA is logged onto. So again, we have to make a choice, an educated guess. So let's say we go to the guy on the top right, and again, we find out what privilege do I have now, and we find out it's nothing new. It's nothing we didn't already have. I hate when that happens. So we have to go back, take a step back, reassess, say, why did we choose this guy? Let's choose a different guy who's a better option. And say, for example, we go to this guy in the bottom row, and we find out, okay, here's his password. Where are the other systems that he has local admin rights on? And lo and behold, who should appear but the domain admin on a system that we now have local admin rights on. So we pivot to that system, we get the DA's credential and clear text out of memory, and write a report, and we feel great, and we're awesome, and like wipe the sweat from your brow, and thank God that you actually completed the project. So we have gone through this kind of attack scenario dozens and dozens and dozens of times. If you read breach reports, like for example, the Target breach report, actual actors go through this kind of attack methodology as well. So back in 2008, Microsoft Research coined the term identity snowball attack. Identity snowball as in you have a snowball that starts rolling down a hill and it gets bigger and bigger, obviously the further it goes. And so as you collect more credentials in a network, your scope of administrator access grows and grows and grows as well. We refer to this as derivative local admin. Our boss, Justin Warner, he defines this as the chaining or linking of administrator rights through compromising other privileged accounts. So this concept is core to the project that we're going to be talking about called Bloodhound. So put into a visual way, let's say you have this user, Bob. Bob has local admin rights on this system called PC1. On PC1 is this user logged on named Mary, and Mary is an admin on PC2. So Bob effectively has admin rights on PC2, and he derives that privilege through stealing Mary's credential from PC1, okay? Another way this can work is with Active Directory security group rights delegation. So you have this user Bob, he's a member of a group called Help Desk. Help Desk is a member of a group called Server Admins. Server Admins has administrator rights to PC2. Bob has administrator rights to PC2 because security rights delegate downward as you add groups into other groups. So, we love this attack methodology. There are certain challenges with it that need to be brought up. First of all, it's extremely time-consuming and very, very tedious work. We wind up having to have like different spreadsheets and tables and trying to keep track of what accounts we have access to. And once you start adding like dozens and dozens of systems and hundreds of users, that becomes just unmanageable, and it's impossible to be effective at it. Secondly is it's not comprehensive. So imagine you deliver your report to your client and you say, here's the path that we took to reach domain admin. Well, you could only really understand that path once it had already been executed, once it was complete. And you look backwards at the breadcrumb trail that you left behind. But imagine if instead of just saying, here's this one attack path, if you could say, here are all of the attack paths. Okay? Third, I don't know if this is working. There we go. When you're going through this process, you have very limited situational awareness. You have the fog of war when you're attacking a network that you don't manage. You can find out a lot of stuff about it, but actually having an idea of the relationships between the computers, the users, and the groups is just not possible. And then finally did you even need domain admin to meet your objective? If your objective was to get access to HR data, you need access to an HR user. You don't necessarily need access to a domain admin account. Certainly it makes your job easier, and it makes your persistence options a lot better. But you may not even need a domain admin in the first place. You might actually be wasting a lot of time. All right. So let's switch gears a little bit. Go back to computer science 102. We're going to talk a little bit about graph theory. Now, when I say graph, I don't mean like a chart, like a pie chart or a bar chart. I don't mean like a graphical thing. A graph is a concept of a branch of discrete mathematics called graph theory or combinatorics. With a graph, you have certain basic elements. First of all, you have vertices. Vertices represent individual elements of a system. So say, for example, Buenos Aires could be a vertex. Then you have edges. And edges connect those vertices. They kind of generically represent a relationship between different vertices. So if Buenos Aires is a vertex and Santiago, Chile is a vertex, if there's a flight between those two cities, that flight information could be a vertex that connects those two cities. And then paths. Paths in graphs represent a way to get from one node to another one, regardless of whether they are adjacent. What I mean by adjacent is if there's a direct flight from Buenos Aires to Santiago, those nodes are directly connected. They are adjacent. But if you're going from Buenos Aires to Seattle, Washington, for example, there's no direct flight, so those nodes are not adjacent. But you can take a path from Buenos Aires to Miami to Seattle, and you have a path. Put a visual way, two vertices in this graph, vertex 1, vertex 2, and they're connected by an edge here called edge, and this would be a directed edge. With a path, again, here you have vertex 1, 2, 3, and 4. From vertex 1 to vertex 4, there is a path, and it goes through vertex 2. From vertex 3 to vertex 4, there is no path because we don't traverse backwards against directed edges. We don't drive the wrong way down a one-way street. Okay. With our tool called Bloodhound, the way that we design our graph is the vertices represent users, groups, and computers in Active Directory. The edges, or the relationships, represent, for example, a user to a computer means that this user has admin rights on this computer. Or from a user to a group, this user is a part of this group. From a computer to a user, that computer has this user logged on. And paths always lead to escalating rights, or always towards compromising another system or user. So let's look at this visually. First of all, we want to find out all of our nodes. So we find out who are the users in Active Directory, who are the computers in Active Directory, and what are the groups and group memberships in Active Directory. So we have two users. We have Bob and Mary. We have two groups, IT admins and domain admins. And we have a computer, server 1. So first of all, we figure out group memberships. And we see that Bob is a member of this group called IT admins, and that Mary is a member of this group called domain admins. Then we find out privilege. We see that IT admins has admin rights to computer called server 1. Finally, we look at session information, or where are people logged on in the environment. And we see that on computer 1, this user Mary is logged on. So, is there a path from user Bob to domain admins? Yes. You follow it by going user Bob is a member of this group, is an admin on this server, where this user is logged on, and they're a domain admin. So as an attacker, this tells me I need to go to server 1, steal Mary's credential, and now I'm a domain admin. So put simply, we need to know who's logged on where. We need to know who has admin rights on what systems, groups or users. And we need to know what users and groups belong to what other groups. So we're going to talk about how we collect that information using PowerView, and I'm going to take a quick drink of water. Are we on time?
I don't have a watch.
Okay. Good? Okay. All right. So has anybody heard of this tool called PowerView? A few people, yeah. Okay. What about PowerShell Empire? Have you heard of that? More, yeah. Same guys are involved in both projects. There was this report that came out from this guy who went by Phineas Fisher. And in his pastebin dump, he said that PowerView was the best tool these days for understanding Windows networks is PowerView. In our experience, this is exactly true. So PowerView, quick overview, it's a PowerShell v2 compliant network and domain situational awareness tool. So it's used for collecting information or collecting data from Active Directory and from computers joined to Active Directory using PowerShell. The v2 compliance means that if you drop on a system that is Windows 7 or Windows Server 2008 or newer, it's going to work, regardless of what version of PowerShell is installed on that system. So one of the key elements of PowerView is that it does not require privilege to collect the data that it's collecting. There are commandlets that do require privilege to collect data, like, for example, from logon event logs from domain controllers. But for our project, all you need is domain user access, and you can map out these attack paths. So for who's logged on where, we refer to this concept as user hunting. There are two commandlets that are central to this concept. One is getNet session. So this uses a built-in Win32 API call to collect information from a remote system of who has a session established to that box. The information you get back from that is a username and an IP address. So we have to kind of massage that into the format that our ingester expects. Secondly, getNet logged on and get logged on local. GetNet logged on does require administrator rights. Get logged on local will actually query the remote registry, which if it's enabled, you don't need admin rights to pull the data from the remote registry. If it's not enabled, obviously either enable the remote registry or just use getNet logged on. So that'll tell us who's logged on where. We also have a stealth option if you don't want to touch every single computer in the domain. So this will identify systems that are heavily trafficked, typically in Active Directory. So that's going to be domain controllers, DFS boxes, systems that are identified as user home directories in the user objects. And it'll only collect session information from those systems. Typically, those are all you have to touch. And you'll get like an 80% view of who's logged on in the environment. So who can admin what? By abusing a legacy WinNT provider that's been in Windows, I don't know, forever. Since Windows NT existed, we can actually enumerate without admin rights who are the local admin users and groups on a Windows box. Why Microsoft decided to make this information available to just any user in Active Directory, we don't know. But our tool wouldn't exist without it, so we really like it.
Backwards compatibility.
Yeah. With PowerView, this commandlet is get net local group, tac computer name, IP address, and then there's also an API option as well. Instead of going to the WinNT provider, the Win32 API. Okay. There's also GPO correlation that you can do to find out what users and groups can admin computers in the environment. This information will typically not be as comprehensive as touching each box in the environment, but it's extremely stealthy, and more often than not, we can find a path by just doing the GPO correlation. So GPOs can be used to set local administrators. The correlation is done by looking at the GPO and looking just at the domain controller itself. So for a better explanation of that, look at the talk that we did at DEF CON, and Will explains it a lot better than I do. The commandlet here is find-GPO location, and then that commandlet will just do all of the work for you to identify local admin users and groups on computers. And then who's in what groups? This is the easiest one of all. In our ingester that we released at DEF CON, this was very simply just get all the groups in Active Directory, and then get all their users. And that's it. So if anybody's ever used Active Directory, you know how easy it is to find out this information. It's super, super simple. All right. So the first version of our ingester had these commandlets here. So using the tool to collect the info, you would do get bloodhound data, and that would just automate and obfuscate away all of these tasks for you. Then you could either export the data to CSV or directly to our database's REST API, depending on what your network situation looks like. If you are an external attacker or if you're internal, what have you. You have options. OK, who wants to see a demo? All right.
You guys thought Andy was going to do the whole presentation. I tricked you all. This part's mine. All right. I am going to make Andy stand up, even though he wants to sit down and point out stuff, because unfortunately, it's a little blurry up there. But we're gonna make it work anyway. All right. So this is the user interface for our tool that we've released. The initial view you get here, our favorite thing that Andy said probably 50 times is domain admins. So the first thing you get to see is who are the domain admins on the network. This whole database here is a nice little fake set of data that Will mocked up for us. It's pretty similar to many networks we've seen, so I don't want you to think this is just BS data. I mean, it kind of is, but you know. So let's walk through some of the cool features here. So this is a pretty small graph. It's a small network that we're simulating, but these graphs can get really, really big. So the first thing we have is what we call the spotlight. This lets you search within a certain graph for any other node that's already in there. So we're going to actually look at a user first. So when you click on a user, it's going to zoom in, show you where it is on the graph, and it's going to pull up a lot of data over here for you. So the first thing you can look at is what groups is this user a part of. So in this case, you can see he's a member of domain admins, executives, a few other things. That's cool. If you do a net user username / domain, this is the data you get back. But now let's take it a little deeper and find out if you unroll these groups, how far do we go? So instead of 6 groups, now we have 21. Let's change this so it looks a little cooler here. So each of these groups that he's in has other groups that it's nested inside of. So in this particular case, you might think, I'm only in 6 groups, what's the big deal? But once it starts going further and further, this is where you start losing track of what permissions people have.
Yeah, so as an example, the gconst user, the user icon right here, he's a member of this group here called executives, so he gains all the rights of that group. But that group is a member of this group called managers, and that group is a member of this group called contracting for some reason. We see this all the time in real environments. So this user has all the rights of all of these different groups.
Now, if you're working with multiple domains, there's something called foreign group membership, which is your user part of a group in the other domain? In this particular case, he's not, so we don't have to worry about it. First degree local admin. If you're on a system and you do net local group administrators, you can see who your explicit administrators are. That's what you would show up for first degree local administrator. This user isn't. However, because of the groups he's in, we can look at where this user has admin rights through his group delegation. So in this particular case, we are a local admin on 184 systems because of the groups that we're part of. Now, if you can see here, there's a little number right next to this group. We can right-click on this and hit expand, and it'll show all the computers that we have local admin rights on. We do this to keep the graphs more compact. Once you start getting into bigger networks, these graphs get bigger and bigger and bigger, so you need some way to squish the data down so it looks better.
One thing I forgot to mention is the data collection part. If you have a network that's like 10,000 computers, the data collection takes about 30 minutes. And then the queries that Rohan is doing here, this is the speed that you run these queries at since they're in the database. The largest network we've done is like 300,000 computers and servers, and that data collection took about 24 hours.
Yeah, these are all live queries. None of this is like pre-set up. The UI is actually running queries directly against the database that's running on my computer right now. Now, back to what Andy was talking about earlier, derivative local admin. This is where Bloodhound really shines. This is what we want to know. Where can we go from where we are? So if you click right here, you get a nice graph. This graph is showing if we start at this user, where can we go using local admin rights, sessions, group membership, anything that it can find to any other computer, it will show you that path. So if you start here and you follow a path all the way over here, you can see it highlights for you. That will take you to the desktop 15 box, which is like 10 hops away. Now, just like we have users, we also have, let's look at a group. Sure. There we go. We got the research group, very generic name. So just like with a user, you can look at all sorts of interesting information over here. First thing you can look at is who are the direct members of this group. In this case, there's 17 members, 13 of which are groups, and 4 of which are users. Now, this is where it gets really fun. You can take those groups, unroll them, and find out how many people are actually part of this group. So in this particular case, there are 39 users that are part of this group. Now, this is actually something that's pretty hard to visualize using native Active Directory tools, because usually all you can see is what the groups are, and then you'd have to look up each of those groups manually. With Bloodhound, because we've queried all the data already, we can just ask the database to unroll it for us, and we can see all these users. This is something we also see people lose a lot of track of. We have a group here, but once you start unrolling the groups and the members, you get more and more people who have access to things they probably shouldn't. You can ask, where is this group direct admin to? So once again, if you ran net local group administrators on any of these computers over here, the group research would be in that group. We can also ask, just like with a user, where we have derivative admin to. Now, this is basically saying if I had a user in this group, where could I go? So if you follow these paths, each of them taking you in different directions, there's lots of folded computers here, but eventually you end up with 263 computers. So it's fun to see these paths kind of just split out further and further. You can see what groups your current group is part of, in this case none, and foreign group membership, is this group part of a group in another domain? Now this is also a really fun function that takes quite a while to do using like native commands. I can ask Bloodhound to tell me for every member of this group, where are they logged in? Let's say you're on an assessment and you know HR has all the data that you want as your target. I can ask Bloodhound, find me the HR group, find me all the groups and users within the HR group, and then show me every computer where they're logged in. So these computers would all be my targets because that's where my data is going to be. Right? And just like we have groups and users, we also have computers. Everybody loves SQL, all sorts of fun things you can do with it. First thing you can query for a computer, explicit admins. If you do a net local group administrators, this is what shows up. This is where it gets fun, though. What are the unrolled admins? This computer that only had 6 explicit administrators actually has 51 users that can administrate it. This is another thing we see people lose track of very quickly as groups continue to become more and more nested. We'll show another really fun example of that.
Real quick, this is not the worst example we've seen in the real world.
Not even close.
We've seen where a computer has 2 groups and 1 user explicitly defined as a local admin. So 3 effective admins. But when you unroll those groups out, it's more than 3,000 people who wind up having admin rights on that system. And it turns out to be like 10% of the organization.
Similarly, we've also seen groups that unrolled from, I think, 3 members of the group to, I think it was 240 groups.
Yeah.
So this happens in real life. I'm not making this up. Another thing you can look at for computers, are computers part of any groups? Believe it or not, we have actually seen a computer that was part of the domain admins group. So if you compromise that computer, you had access to the entire domain. Very bad, please don't do that. But if you do, do it right before we come for your assessment. You can look at, is this computer an admin on any other systems? Once again, this has happened in real life. It's very rare, but if it's there, it's a great method of accessing another system. Just like with users and groups, we can ask, where do we have access to? If I was on this computer and I had admin rights, this is everywhere I could go based on that access. This is using, once again, local admin rights, sessions, and group membership. And you can ask, who's logged onto this computer? Now, this is all really cool stuff, but I want to get to what makes Bloodhound really, really powerful here, which is pathfinding. Because we're using a graph database, we can ask Bloodhound to show us a path from any point A to any point B. So I'm going to close this here and open our handy-dandy pathfinding window. If this looks like Google Maps, it should because we copied it. So let's pick a user, Jay Druin. He's in the external.local domain. So let's ask, how can I get to domain admins at external.local? That query ran just like that. So if you start at this user over here, Jay Druin is part of the Information Technology 3 group, which has local admin on all these systems right here. And then we have 3 users who are logged into those systems who are all members of the domain admins group. That's a 4-hop path. It's pretty simple. This is something that we see all the time. Now, let's make it a little bit more complicated. How many of you guys have experienced domains where they have, networks where they have multiple domains, and you have to go from one domain to the other? It can be really tedious, really time-consuming, and the data is hard to find. Thankfully, we have Bloodhound. So instead of going to domain admins at external, let's go to internal.local. So this path's a little bit more complicated here. We start at the user Jay Druin. We're part of the Information Technology 3 group, which has admin to desktop 11. Now, on desktop 11 is a user administrador. However, this user, despite being in the external.local domain, is part of a group in internal.local. So from this hop, we've actually crossed a domain trust boundary. Now, if you follow this through the end, this group is part of another group, which is part of another group, which is part of another group, because why not? And you get local admin to 2 systems here. This user here is logged in, A. Sanders, who's a member of the domain admins at internal.local group. We just started in the external.local domain and achieved essentially a full compromise of the internal.local domain just by following a path that Bloodhound queried without any actual issues. That's one of the biggest powers of Bloodhound, is the ability to go from anywhere to anywhere.
The best real-life example of that is we had a client that is a global enterprise with hundreds of thousands of computers and hundreds of domains in multiple forests. And we were able to take a relatively low-privilege user in a small domain and turn that into enterprise admin in the central, root domain by crossing 9 different domain trust boundaries and abusing users that had relatively low privilege in the environment. They had admin rights to 5 or 6 systems, but they had admin rights to those systems that got us that next step level access, which Bloodhound found no problem.
All right, if you couldn't tell from this, we're really lazy and we don't like doing actual work. That's why we automated it all. So we built pre-built queries that you can use if you use this tool. First one you start with is find all domain admins. This is where we started. This is the initial view that we had. Now this one's really fun. This is one thing I love showing to clients. Find shortest paths to domain admins. Now, Andy was saying, when we usually did assessments before Bloodhound, we could find one path to domain admins, report it to the client, and show this is how we did it. I don't like that. I want all the paths. So we're going to ask Bloodhound to show that for us. So we're going to select our domain admins at external.local here, and you get this crazy graph. Now, from any one of these users that you see here, there is a path from that user all the way to the domain admins at external.local group. And as far as Bloodhound is aware, this is every single possible path you can take to go to the domain admins. One really cool thing, this whole graph is interactive. I can drag this node out and say, this file server 6 right here, this is a high-value target because so many of the paths on this domain go through it. So if you were to tell the client, if you can fix something on this box, this might be a great way to reduce the number of paths that attackers can take.
I think we're almost out of time.
Oh, we're almost out of time?
Yeah.
All right, I'm going to skip all this stuff then. We're just going to pretend like I went through it, though. Now, I do want to say that one thing we like is that Bloodhound is completely free. It is open source. It is available on GitHub. Mm-hmm. We want people to use this, both defensively and offensively. Every part of this is free. This is not supposed to be restricted in any way. We actually have a link here for you, if you guys want to check that out. That will redirect to our GitHub repo and not any malware, I promise. Neo4j, which is the graph database which we use on the back end, is completely free for the community edition. We do have pre-compiled Bloodhound binaries for both Mac, Windows, and Linux, so you can run it on any platform. We even have it for ARM v7 if you want to run on your Raspberry Pi. I don't know why you would ever do that, but go ahead if you want to. If you don't trust our binaries, you can compile it from source yourself. It's all there. I won't feel offended, I promise. Do we have anything else? You want to talk about ACLs really quick?
Maybe offline.
Okay.
So we're gonna go into the next room for questions. We'll probably try to grab some food with you guys too. So shout out to Linkurious.js, a French startup. Also shout out to Emmanuel Gras and Luca Bouillot. They're from a French IT audit agency from the French government. They had a project that was very, very similar to Bloodhound that came out 3 years ago that abused Active Directory control paths, which, based on their work, we were able to accomplish this, and then we're also going to be able to accomplish the next step of Bloodhound, which is including control paths through abusing ACLs that are misconfigured. You can find me on Twitter @_Waldo with a 0. You can find Rohan on Twitter @CPTJesus. Will Schroeder, you can find him on Twitter at harmjoy with a 0. We'll put the GitHub link back up, possibly. Or if not, come say hi to us in the next room. We would love to answer your questions there, and enjoy your lunch.